Okay, hello and welcome to this week's topic, which is blood. Now, physiologically, when we look at blood, we look at basically what the constituents of blood are and what the purpose of each of those constituents are. Medically speaking, blood is an extremely important part of our investigative package. Blood can tell us so much so quickly about what's going on inside of the body. And in terms of invasive procedures, taking a sample of blood, whilst not pleasant, is really quite on the low end of medical intervention, shall we say. So, first of all, in order to be able to understand what a blood report would tell you, you need to understand what's inside blood and therefore what will show up on any given blood report. So, these next series of 4 to 5 lectures will look at that, and we're going to start with the smaller half of what we find in blood. So the blood basically is made up of two parts. It's made up of the formed elements, which is a fancy way of saying the cells that we find there, or parts of cells that we find in blood. And the second part is the liquid phase, which the formed elements float in. And that's what we call the plasma, and we'll look at the plasma in the next lecture. So we're going to look at formed elements and what that means. And behind me on the board, as usual, I've written up some information that we can use to help us understand what we're looking at. So inside human blood we have formed elements, which are cells, and there are three types, main types, and then we have some subtypes in the white blood cells. So what are the three types? Well, we have red blood cells, correctly referred to as erythrocytes, and then we have white blood cells, correctly termed leuco, because leuco is white cytes, so that's white cells. And then we have platelets, which come from megakaryocytes, and they are correctly termed thrombocytes, or clotting cells. Okay, so of these three groups, the red cells are by far the most common. In 1 ml of blood, you will find 5 to 7 million of these little red blood cells in that 1 milliliter of blood. Compare that to white cells, which they'd only find 4 to 11,000, so that's almost a 1 to 1,000 difference. For every one white blood cell you'll find 1,000 red blood cells. And then slightly more numerous than white cells, we've got the platelets, which are actually parts of cells. They're fractionated megakaryocyte cells. And between 150 and 250,000 would be a normal range for your platelets. So what do they do? Well, the red blood cells, most numerous by far, carry oxygen to the cells so we can have cell respiration. Now we've already looked at that in this course, so now we're looking at the phase of the blood, the red blood cells, which actually carry the oxygen there to allow the full process of cell respiration to occur in the mitochondria. So that's their job. They're very, very small, 7.5 micrometers in their diameters, which is about, the smallest capillaries are about 7 micrometers, so these actually have to squeeze through those to get by, and they're biconcave, donut looking cells. They're both anucleate and amitochondric, so they don't have mitochondria, so they can't produce lots of energy, and they don't have nucleus, so they can't produce proteins, so this limits their lifespan to roughly about 120 days from when they're produced to when they're removed by either the spleen or the liver. Moving on, white blood cells, and these will be looked at in detail when we look at the immune system. They're involved in the immune response, and 4 really of the 5 groups are involved in the non-specific side, and then the lymphocytes are involved in the specific immune response, which at this time may not mean a lot because we haven't looked at it yet, but keep that in mind for when we get there. There are 5 main groupings of cells that we see under the microscope. And when they were first looked at under the microscope, they were split into what you could physically see through the microscope. So what we noticed first was that three types of cells had these kind of dots inside the cell itself called the granules. And so these were the granular white cells. And then two types were clear. They didn't have those granules sitting there, so they were called agranular. So originally we had 3 as granular and 2 as agranular, which is why you'll see in textbooks them written up that way. More research elucidated more about them, and so what we know now is that we've got these 5 types. We've got neutrophils, eosinophils, basophils, monocytes, which when activated become macrophages, and lymphocytes. In fact, I'll put that in brackets just so we remind ourselves. Macrophages. So what do they do? Well, they're all part of the immune system, but they all have different roles. Neutrophils are like the ground troops. They arrive first to all breaches of the blood vessels and tissue damage. So they are by far the most numerous, and they're there, they arrive at the start, and they're phagocytes, so they start engulfing any of the bacteria or anything else it finds there and starts trying to break that down and destroy them. So this is our ground troops, if you like, our first responders. Eosinophils, these tend to be more involved in allergic responses and parasitic infections, such as parasitic worms. So these are much less numerous than neutrophils. In some blood reports you won't even find any if there's no current issue with either allergies or parasitic infections. But when they are stimulated, they will attack these particular things. They'll also be able to take out tagged cells, etc., by the specific immune system, the antibodies for destruction, so they can phagocytize those too. Basophils, they're full of granules because they contain histamine and heparin. Heparin keeps the blood thin and lets it flow, and histamine causes vasodilation to allow more blood to flow into. These two work very well together. The histamine creates a wider vessel, so more flow of fluid, and the blood thinner means that as more blood is coming into this area, it's not sticking together or getting stuck, it's flowing quite well. So basophils are found in the blood. The cell type that does similar in the tissues would be the mast cell. So keep that in mind when you see a mast cell. It's basically a histamine producing cell in the tissues, which has the same response. Monocytes, these are the tanks of our military. Whereas we have the ground troopers, the first responders here, these monocytes are actually a lot larger, but they take longer to arrive at the site of damage. So 8 to 12 hours after the original event, these guys will be acting like the cleanup crew, will be arriving and picking up anything that's left and destroying it, also by phagocytosis, which is the engulfing of the offending bacteria, for example. They'll even engulf the neutrophils which are there, which have already engulfed the bacteria, and destroy them as well. They'll just clean up the whole area. So these 4 are all involved in the non-specific. When we look at the immune system, we'll find that these link to the specific site as well as antigen presenting cells. So finally we have the lymphocytes, and the lymphocytes are the specialist cells. So we have T lymphocytes and we have B lymphocytes. And I'm not going to get too much into that, except to say that the B lymphocytes work in the plasma, T work in the tissues. Under microscopy we can see their different shapes. So it's like a horseshoe shape for the neutrophils, bilobes for the eosinophils and basophils, and acid wash stain. The granules are red for eosinophils and sort of purplish blue for the basophils. The monocytes have a big kidney-shaped nucleus and they're clear, and the lymphocytes, the nucleus is large and there's only a thin sliver of cytoplasm outside of it, because their job mainly is to produce proteins, and proteins are coded for in the nucleus. So we have 4 to 11,000 of these per mil of blood. If you have a white blood cell count which is greater than 11,000, say for example 15,000, that's indicative of an infection. If it's high because the neutrophils are high, that's indicative of an acute infection, because remember, these guys are first responders. If it's got a high amount of monocytes in it as well, that's suggestive, and also lymphocytes, that's suggestive of a more chronic infection. It's been running for a while, these guys have dropped down a bit, these guys have increased over their normal, then that's a longer going infection. But anything over really 11, 12,000 for your white blood cells is indicative that you have an infection, and it's most likely bacterial. Below 4,000 means that you have leukocytosis, which is a lack of white blood cells. Now this could be for many different reasons, particularly if you've been on chemotherapy or something like that, and it also means that you're immunocompromised, meaning that you don't have enough circulating white cells to mount an immune response to the various pathogens that you're exposed to. So again, it's something to be very careful about. Going back to the red blood cells or erythrocytes, when we have too few of these, then we have what's called anemia. Now interestingly, anemia, which is essentially a lack of oxygen carrying cells, whether it be due to the fact the red cell itself or the hemoglobin inside, there isn't enough of that, or it's been compromised in some way, like binding of carbon monoxide. Anemia itself is not a diagnosis, it's just a finding which then leads you to look for what's caused the anemia in the first place. And there are many different types of anemia. The most common really is probably iron deficiency anemia, where we just simply haven't consumed enough iron in our diet, and therefore at the center of our hemoglobin, the iron sits there and actually binds the oxygen to carry. So without enough iron we can't carry enough oxygen, hence we have anemia. Alright, so finally platelets, thrombocytes. Now the platelets are just fractions of cells, they're not a whole cell, they don't need to be, and they contain different chemicals that they release when they're exposed to foreign substances. And the most common reason why this would happen is because the blood vessel itself, if we draw a tube here, here's our blood vessel, and here's our tube there, and here are our red cells going through, and our platelets, etc. And so the blood's flowing that way, and then suddenly there's a break here, there's damage, and so the underlying tissue, like collagen, which is holding this together, is now exposed, and all these little platelets start to be attracted to the charges on the collagen, because the endothelium of the blood vessels are very smooth and don't have any charge, so that everything flows straight by it. But as soon as that becomes available, the platelets start becoming sticky and they start releasing chemicals, causing a vasospasm. But we're going to look at that in a later lecture anyway. So these are our three formed elements making up 45% of the blood volume. Most common, red blood cells. Next most common, platelets, and then followed by white blood cells. And we have our 5 types of white blood cells, and with their basic functions. So thanks for listening.